Hello, in this video I'm going to talk about dilatation. Thermal expansion is the process by which bodies increase their volume when their temperature increases. When instead of increasing the reduced temperature, the volume of the body also does, speaking in this case of thermal contraction. So most substances dilate or expand when heat and contract when cooled. For example, in the case of a glass thermometer, remember that the thermometer inside contains mercury. So if we have an increasing temperature, both mercury and glass are going to dilate or expand, but they do it differently. Mercury in this case has a greater expansion, causing the volume of mercury to increase, recording the value of the temperature. The dilatation is also known as thermal expansion because it depends exclusively on temperature variation. It applies to the three states of matter: solid, liquid, and gases. There are three types of dilatation. Linear dilatation in solids, for example, Cooper bar. Surface dilatation in solids, for example, steel plate. And cubic or volumetric dilatation in liquid, solid, and gases. Linear dilatation occurs when we have a bar-shaped body. Consider a bar that has an original length of L0 at a temperature T0. Then we'll increase the temperature so the bar will show a dilation when it has brought to a final temperature called Tf. We see that an increase called delta L has been delayed and the final length of the bar is called L. So delta L is equal to the coefficient of linear dilatation of the bar material called alpha multiplied by the initial length L0 multiplied by delta of T, which is the temperature variation. Delta T is equal to final temperature minus initial temperature. Now, L is equal to the initial distance L0 plus delta L. Replacing delta of L in this equation and then factoring L0, the formula is obtained to calculate the final length of the bar after being subject to a variation of temperature. Linear dilatation example. A copper bar measures 90 centimeters when it is at 20 Celsius degrees. What will be its length at 100 Celsius degrees? Initial data. The coefficient linear dilatation of the material is equal to this, and initial temperature is equal to 20 Celsius degrees, and final temperature is equal 100 Celsius degrees, and initial length is equal to 90 centimeters. Now, delta T is equal 8 Celsius degrees. Replacing the data in the equation seen above, it's obtained for this example that the final length of the Cooper bar is 90.12 centimeters.